Good morning. In our previous session, we have discussed about electroplating, types of electroplating. So, electroplating is a method of depositing one metal on the surface of another metal using DC power supply. So, I have mainly two types of electroplating methods: anodic consumption method and electrolyte consumption method. So this electroplating is governed mainly by three principles: polarization, decomposition potential, and over voltage. Let us discuss these one by one. Polarization, polar. What do you mean by polar? So polar means two different ends. One negative, other one is positive. So with respect to metal finishing, polarization is defined as decrease in electrode potential due to inadequate supply of metal ions from bulk of the solution to the vicinity of the electrode. So here, what do we mean by electrode potential, inadequate supply, vicinity? We'll discuss briefly. So in any cell, we have an anode, cathode. For instance, in electroplating cell, we'll have a electroplating process. Anode is must, cathode is must, and electrolytic solution or electrolyte or a plating bath solution is must. So anode might be inert or coating material itself, but by default, cathode is the base metal or metal which takes coating. So here, since cathode is the metal which takes coating or where deposition occurs, cathode is very important to us. So here we are going to separate the anode. We are going to determine the polarization, or we concentrate only on the surface of cathode. So we are going to take cathode, dip it in a solution which contains metal ions. So we're going to determine the electrode potential of that particular cathode as it is represented in the diagram. So if you want to determine the electrode potential of that, it is determined by Nernst equation as given in the slide. It is E equals E naught plus 0.0591 by N log concentration of Mn plus. So before passing current, the concentration of Mn plus is equal throughout. Therefore, we get some potential. Now, we're going to pass current. When we pass DC power supply, the metal ions undergo reduction reaction as shown here. Mn plus N electrons gives M. And this metal gets deposited on the surface of the cathode. So, which metal ions undergo reduction here? Here we'll have two types of metal ions. What are those two types of metal ions? If this is the metal, so the cathode, the metal ions present nearby the metal ions or surrounding the metal ions is called as vicinity, and far away surface, this surface is called as bulk of the solutions. Metal ions present in the vicinity undergo reduction first compared to the metal ions present in the bulk of the solution. So therefore, there exists a difference in concentration in metal ions present in the bulk of the solution and vicinity of the electrode. Therefore, electrode potential will decrease as shown in the diagram here. So if you want to get back the original electrode potential, the metal ion should diffuse from bulk towards the vicinity of the electrode. If the process of diffusion of metal ions from bulk towards the vicinity is slow, then the electrode is said to be polarized, and the process is known as polarization. That is, I repeat, if the metal ions diffusion from bulk of the solution towards the vicinity is low, then electrode is said to be polarized and the process is known as polarization. So what if electrode is polarized? So what? So it is very important in industries. So major disadvantages: the galvanic cell develops smaller potential than the predicted. So for instance, if you take a Daniell cell, its output is 1.1 volts. If it is polarized, we get lesser potential. In electrolytic cell, if the cathode is polarized, then you're supposed to supply more negative potential. Now the question is how to prevent the cathode from undergoing polarization. So we can stir it. So when you stir it, what will happen? Then equal concentration of metal ions can be maintained throughout the solution, whether it is vicinity or bulk. Only one thing, that is to prevent polarization, metal ion concentration should be equal throughout the solution. That can be maintained by increasing temperature. That is, if increase temperature, conductivity will increase, thereby metal ion movement from bulk of the solution towards the vicinity will be equal, therefore polarization reduces. Increasing rate of stirring, adding depolarizes, making electrode surface rough, or using large electrode surface. By using these precautionary measures, we can prevent polarization. Our next governing principle for electroplating process is decomposition potential. So what do you mean by decomposition potential? So decomposition potential is the minimum external voltage which is applied greater than back EMF in order to bring out continuous electrolysis process. That is known as decomposition potential. Now the question is, what is back EMF? So for instance, let us consider the electrolysis process of an acid or a base using two platinum electrodes. When you are using two platinum electrodes, so what happens? Electrolysis will start and it will stop very soon. Why? Because the back EMF will exceed the applied voltage. What is this back EMF? When electrolysis starts, there will be products of electrolysis. For example, let us consider the electrolysis of water. So when electrolysis of water occur, the products of electrolysis are hydrogen and oxygen. This hydrogen and oxygen will get deposited on the surface of this anode and cathode. It will get deposited on the surface of anode. If this is anode, it will get deposited on the surface of this anode and this cathode. So what will happen? Because of this will develop a potential. These electrodes will develop a potential which is in the opposing direction of the applied voltage. And that potential developed by these electrodes is known as back EMF. Why it is termed back? Because this potential is opposing the applied voltage. So here electrolysis will continue until the back EMF is lesser than the applied voltage. Once the back EMF exceeds the applied voltage, electrolysis will stop. Now, if you want to have a continuous electrolysis process, then we are supposed to increase the applied voltage greater than back EMF. So that minimum or additional voltage greater than back EMF is applied in order to get continuous electrolysis process is termed as decomposition potential. I repeat, that minimum or additional voltage greater than applied voltage or greater than back EMF is applied in order to keep electrolysis process continuous is known as decomposition potential. It is diagram or graphically represented as follows. This decomposition potential is theoretically determined value. Next governing principle is overvoltage. Overvoltage, the voltage that has to be applied greater than theoretically determined decomposition potential in order to maintain continuous electrolysis is known as overvoltage. So now for electrolysis of dilute sulfuric acid, the theoretically determined theoretically determined decomposition potential as 1.23 volts. When we applied this theoretically determined decomposition potential, electrolysis will start, but after some time it will stop. But what is decomposition potential? When you apply that decomposition potential, it will start, right? But that's not happening. Most of the cases, theoretical value will not match with practical value, isn't it? So what will happen in sulfuric acid? When we apply 1.23 volts, it will start and it will stop. So then we'll slowly increase. So see that at what voltage the electrolysis process is continuous. It was observed that at 1.7 volts, there the electrolysis process was continuous. So that 0.4 volts extra voltage which we applied greater than decomposition potential to keep the electrolysis process continuous is known as over voltage. So decomposition potential is a theoretical determined value, whereas over voltage is a practically applied value. The factors affecting the over voltage are temperature, current, electrode potential, and rate of stirring. So let us discuss, keeping this, how plating occurs. We'll discuss in our next session. Thank you.